Jai Hind dear students, I am Dr. Preeti Mittal and today we are going to discuss the NCERT questions of chemical reactions and equations. We are not only just going to discuss the questions that are given in your NCERT book, but apart from that also, with every reaction, we are going to consider which type of reaction is that. Because the most probable questions that are asked in your exams from this chapter are to balance a chemical equation. Second thing is to write the type of reaction. Apart from that, whatever theory we have covered, that could be asked in the form of questions. So we'll discuss some extra questions also that are not given in the NCERT book. But let's start with that. Before I start, I would just like you all to subscribe to my channel, share it with your friends if you like the content. So let's start. First, the questions given on page number 6 of your NCERT book. The first question is write a balanced chemical equation for the following. So the first one, that's question number 2. Question number 1 we have already discussed in the videos that why magnesium ribbon needs to be rubbed before burning that. So the questions that we have already discussed in the videos that we are not going to repeat from the NCERT book. Okay. But before watching this video, if you haven't watched the earlier 3 videos of the same chapter, I would suggest you all to just refer to those videos so that you have a concept clarity, and then when we work out the questions of NCERT book, just work it out by yourself, pause the video and just check whether your answer was correct, is it matching with mine, or do you know something extra? Just let me know in the comment section. Write a balanced chemical equation for hydrogen gas combines with chlorine to form hydrochloric acid. Now in these questions they are not asking the type of reaction, but we haven't discussed it along with the chapter for the reason that with every reaction we will be discussing that which type of reaction is that also, because that's really very important for your exams, and that will be like a recap for all the concepts from the chapter. So the first one is hydrogen combines with chlorine to form HCl. So it's very easy. It's question number 2. First part, hydrogen is gas, combines with chlorine to form HCl, hydrochloric acid. So you can see that 2 hydrogen atoms are there, 2 chlorine atoms are there. So HCl should be, 2 molecules of HCl should be formed. Which type of reaction is that? So that is a combination reaction. You all know that whenever 2 reactants combine together to form a single product, that is known as a combination reaction. Now, second one is barium chloride combines with aluminium sulfate to form barium sulfate that occurs at white precipitate that we have seen in the experiment also, and aluminium chloride are formed. That is aqueous state. Barium sulfate is solid. Rest all the 3 are in aqueous state, that is dissolved in water. Okay. So let's balance this equation. Here we have 3 sulfate ions. Here we have just 1. So to balance it, we have to make it 3 here as well. Now you can work out it separately for sulfur and oxygen. But I always prefer that it's a polyatomic ion. It's together only here also and that side also. So just consider together, that will make our work easier. Now, if we take about aluminium, this side it's 2 aluminium atoms, here it's just 1, so I'll make it 2. Now, comparing the other, barium, this side it's 3, it's just, this side is just 1, so let's make it 3 here as well. Now, consider chlorine atoms, 3 times 2 is 6 this side, and on right hand side also 2 times 3, that is 6 that side also. Okay. So that is a balanced chemical equation for this. Now, type of reaction, just work it out by yourself, think by yourself, and then I'll let you know. So this is an example of double displacement reaction, because exchange of ions is taking place. Apart from double displacement, it's also a precipitation reaction, because white color precipitate of barium sulfate is formed. We have seen that in experiment. So it's double displacement as well as precipitation reaction. Fine. One more thing, remember, none of the double displacement reactions could be redox reactions. Okay, double displacement reactions are never an example of redox reaction, and all displacement reactions are examples of redox reactions. Okay, these are some tips that will really help you out in your exams. Just remember that. Now, the third one, sodium combines with water. In the third chapter, I will show you this as an experiment as well, that sodium combines with water. That's a very exothermic reaction actually. So what will be formed is NaOH plus hydrogen gas will be liberated out. Okay, hydrogen gas will be liberated out. This is an example of a highly exothermic reaction. But you can't make it out. You just experience that with experiments only. I'll show you the experiment in the later videos. Okay, so this is an example of exothermic reaction because the hydrogen gas is produced here, and you will see in the experiment that it was going to catch fire because it's a highly exothermic reaction. Fine. So these are three parts of the question number 2. Now coming to question number 3. In question number 3 in the book, they are asking you to balance the chemical equation and also write the state symbols. Okay, so you have to write the symbols showing the state in which these reactants and products are present. So the first one is solution of barium chloride and sodium sulfate in water reacts to give insoluble barium sulfate and solution of NaCl. So let's work it out how to write that. Barium chloride and sodium sulfate are there. Question number 3, first part. Barium sulfate is there and it's reacting with sodium sulfate. Barium chloride is there, sorry. Barium chloride is there and it's reacting with sodium sulfate to form sodium chloride and barium sulfate that is formed as a white precipitate. Okay, the reaction is quite similar to this one. Okay, and this reaction we have worked out in the experiment also. We have seen the experiment for this reaction only. Now here it's barium chloride and sodium sulfate in water. In water means they are dissolved in water, means their state will be aqueous. We represent by AQ. AQ shows that it's dissolved in water. Here sodium sulfate also, it's dissolved in water. NaCl, that will be formed again dissolved in water, and barium sulfate precipitate will be there. So precipitates are always solid in state. Okay, so for precipitates we write solid state, rest of the three, all the three are in aqueous state because they are dissolved in water. Now next one, sodium hydroxide solution in water. For this first one, I need not tell you which type of reaction it's a. It is a double displacement reaction as well as a precipitation reaction. Second one is NaOH solution in water, means NaOH is aqueous because it's solution in water. Reacts with HCl, reacts with hydrochloric acid, that is also aqueous because it said hydrochloric acid solution in water. To produce NaCl solution, what will be formed? NaCl solution will be formed, means aqueous again, and water will be formed, and water you all know that will be in the liquid state. Okay, now which type of reaction is that? Right now you can say that's a double displacement reaction because Na is taking up Cl from hydrochloric acid, but later on you will study about neutralization reactions. That is when a base react with the acid that forms salt and water. Okay, that we will read in some other chapter. So you can just remember, write it down, note it down in your book or notebook, wherever you're noting down. So this is an example of neutralization reaction as well as double displacement reaction. But it would always be better to write it as a neutralization reaction because neutralization is taking place, base is NaOH, that reacts with acid, that is HCl, to form salt and water. You have heard about a neutralization reaction in your previous classes also. Okay, so I'll just shift aside. You can take a screenshot of the if you want. Now the questions given on page number 10. It's given as an activity that what happens when barium hydroxide reacts with ammonium chloride. Which type of reaction is that? Okay, so let's see to the reaction first, and then we'll see to an experiment and prove that experimentally that which type of reaction is that. Let's check it with a thermometer. Okay, so the question that's given on page number 10 is barium hydroxide reacts with ammonium chloride to form barium chloride, ammonia and water. Now let's balance it. So we can start with barium. It's already balanced. Now if we look at hydrogen, here we have 4 hydrogen atoms and here we have 2. So it makes a total of 6. But this side I have just 1 NH3. Okay, to make it so not hydrogen, yeah, na? Yeah. So it's 6 this side and it's just 3 this side. To make it 6, I will, this side only 3 atoms of hydrogen are there. To make it 6, I'll multiply it with 2. So I'll be getting 2 molecules of ammonia. But now nitrogen is not balanced. So to balance nitrogen, here also I'll make it 2. Now let's see about other elements. Chlorine, it's 2 this side. On the right hand side also it's 2. So it's balanced already. If we take about barium, that is also balanced. Consider about oxygen. This side it's 2 and this side it's just 1 only. So we have to make it 2 this side as well. So now let's count about hydrogen, because earlier we have balanced hydrogen, but after adding 2 to ammonia, that's has become double this side. So it's 4 plus 4 times 2, that is 8 hydrogen atoms this side. And here we have 3 times 2 is 6. 6 plus 4 is 10 this side, and this side also 8 plus 2, that is 10. So hydrogen is also balanced, it's 10 on both the sides. Okay, so this is the reaction between barium hydroxide and ammonium chloride, that is just given as a question, that whether it is a exothermic reaction or an endothermic reaction. Endothermic reactions are those reactions in which heat is used up. All the decomposition reactions that we have seen the thermal decomposition of lead nitrate, that is an example of endothermic reaction because it's requiring energy. Photosynthesis requires sunlight, so that is also an endothermic reaction. Apart from that, electrolysis of water, that is breakdown of water into hydrogen and oxygen by passing electric current, that is also an endothermic reaction. So all decomposition reactions, apart from that, this reaction of barium hydroxide with ammonium chloride, they are all examples of endothermic reactions. Now let's look at an activity to find out. Now let's check it with a thermometer to find out whether this reaction is endothermic or exothermic. Now let's perform an activity to show endothermic and exothermic reaction. So in this test tube I have taken some water. I am adding laboratory thermometer to it. I hope the reading is visible to you all. Now I am adding sodium hydroxide pellet to it, and let's see if the reaction is exothermic or endothermic in nature. Just focus on the reading. I'll just shake it a bit so as to mix the contents. Now you can see the temperature slowly rising up. So you can see this is an example of exothermic reaction in which heat is produced. Now, in the second test tube, I have taken barium hydroxide and I am adding ammonium chloride to it, and I'll be putting the thermometer in that to observe whether the reaction is endothermic or exothermic again. So I'm adding ammonium chloride to barium hydroxide. I'll just shake it, and now let's put a thermometer to this to see whether the reaction is exothermic or endothermic. So you can see that the reading in the mercury level in the thermometer is falling down because this is an endothermic reaction, and the temperature, you can see it's falling down and the mercury level is lowering because reaction of barium hydroxide and ammonium chloride is an endothermic reaction in which barium chloride, ammonia gas and water are formed. So I hope you are able to see that change in temperature. So apart from endothermic reaction, we have seen an example of exothermic reaction also. Then whenever a strong base like sodium hydroxide is added to water, that is a exothermic reaction. Apart from that, many other examples of exothermic reactions are there, like burning of coal. Apart from that, respiration is also an exothermic reaction. Why exothermic reaction? It's given as a question and also in your NCERT book. So respiration is considered exothermic reaction because during respiration, energy is produced, that is stored in the body in the form of ATP, adenosine triphosphate. So that is why respiration is also an example of exothermic reaction. Photosynthesis endothermic, respiration is exothermic. Now, look at the questions given on the page number 10 in the form of questions they have given. Question number 1 is, a solution of substance X is used for whitewashing. So, we are not using X for whitewashing. We are using the solution of X for whitewashing. You have to name the compound X and write the reaction of X with water. Okay. So, it's question number 1 given on page number 10. So, X is calcium oxide. Do you remember that? We have discussed that in the theory portion also. So, the X is calcium oxide, and reaction of this calcium oxide with water will be like this. So, that will be forming calcium hydroxide, CaOH whole twice, and the CaOH whole twice is used for whitewashing. This calcium hydroxide is used for whitewashing of the houses. Okay, so that is X is calcium oxide, and this is a reaction for calcium oxide reacting with water. I hope it's clear. Now come to page number 20. Why color of question number 1. Why color of copper sulfate solution change when iron nail is dipped in that? So we have seen that also in the form of an experiment in the previous video, that copper sulfate is blue in color, but when it reacts with iron, that forms ferrous sulfate, FeSO4, and ferrous sulfate is greenish in color. It's having a green color. So because of the formation of ferrous sulfate, that is the change in the color of the solution. Okay, so the solution is changing its color because of formation of ferrous sulfate, and this is an example of displacement reaction because iron being more reactive than copper, it displaces copper from copper sulfate solution. Now next one is one of my favorite. Question number 2 we are not discussing, we have already discussed that in the theory portion. Question number 3, identify oxidation and reduction. So before we do that, I'll just shift aside. You can take a screenshot if you want so that I can erase the board. Now, the next question is identify oxidation and reduction. So it's question number 3. In this first one is sodium combines with oxygen to form sodium oxide. sodium combines with oxygen to form sodium oxide. So here I have two oxygen atoms. Here I have just one. So to balance that, we have to make it two here as well. Now four sodium atoms have to be there. Okay. Metals are always written like this because metal doesn't form bond with other metal atoms. Okay. So like oxygen we write as O2 because non-metal form bond with another non-metal that we will see in chapter number 4, carbons compound, that they form covalent bond. But one metal doesn't form another bond with another metal, so they are not combining together. So metals are always written as whatever is a metal, that's written like that only, not Na2 or Na4, that doesn't exist. Okay, so it's 4Na. Fine. So that is there, and oxygen, and this is a. This is an example of which type of reaction? This is a combination reaction. Apart from that, this is also exothermic reaction. Sodium is highly reactive metal. Now you remember the reactivity series. So it's a highly reactive metal. So it reacts with oxygen present in atmosphere and starts burning. This is an example of highly exothermic reaction as well as a combination reaction. Now let's see to the thing that is asked in the question, that is oxidation and reduction. So since oxygen is combining with sodium, so this is an example of oxidation reaction. And whenever there is oxidation of one of the substances, one of the reactants, automatically there is reduction of another one. So oxygen is undergoing reduction. There is reduction of oxygen. Now, which is the oxidizing agent? So, sodium is getting oxidized. Who is helping sodium to get oxidized? That is oxygen. So, oxygen is oxidizing agent and oxygen is getting reduced. So, what is helping oxygen to get reduced? That is sodium. So, sodium is reducing agent. Sodium is reducing agent. We have discussed all these concepts in the theory portion. Now, next one is copper oxide combines with hydrogen to form copper and water. So, we have seen that also in the previous video. Copper oxide was black in color, if you remember. When we heated copper, it reacted with oxygen present in the atmosphere to form black colored layer, black colored powder, that is copper oxide. But now when we pass hydrogen through this black color powder, we observe that again brown color substances form, that is copper, and water is formed. Okay, since copper oxide is getting converted to copper, means there is removal of oxygen, and removal of oxygen is known as reduction. So there is reduction of copper oxide. Which substance is getting reduced? So that is copper oxide. And there is oxidation of hydrogen to form water. Oxidation of hydrogen is taking place to form water. Right? So that is a oxidizing agent and reducing agent if we work out. So it's getting oxidized. So what is helping it to get oxidized? That is copper oxide. So copper oxide is a oxidizing agent and copper oxide is getting reduced. So what is helping it to get reduced? That is hydrogen. So hydrogen is a reducing agent. I hope the things are clear to you all. Now coming to the exercise questions from your NCERT book that are given at the last of the chapter. Okay, so we are going to discuss now the exercise questions. I'll just shift to side once again so you can take a screenshot. I hope you have taken the screenshot. Now, exercise questions. Question number 1 is lead oxide is combining with carbon to form lead and carbon dioxide. In this reaction, you have to identify which substance is getting oxidized and which substance is getting reduced. It's quite similar to that of copper oxide only. So the first one is lead oxide. If you have any doubt in writing the molecular formula, please refer to the video in which I have explained how to write the molecular formula. Lead oxide combines with carbon to form lead, and carbon dioxide are formed. Now let's balance that. So here two oxygen atoms are there. Here it's just one. So to balance it, I have to make it two. But now two lead atoms are there. So here also it needs to be two. Carbon, it's one on both the sides. So it's already balanced. Since carbon is combining with oxygen, so this is oxidation. Since there is removal of oxygen from lead oxide, so there is reduction of lead oxide. So the substance which is getting reduced is lead oxide. The substance which is getting oxidized is carbon. Now oxidizing agent and reducing agent. So since carbon is getting oxidized itself, it is a reducing agent. And since lead oxide is getting reduced itself is an oxidizing agent. It's just the work of opposites. Okay. Now second part. Fe2O3 combines with aluminium to form Al2O3, that is aluminium oxide, and iron. Okay. Fe2O3 is ferric oxide. Wherever the valency of iron is +3, that is known as ferric. And whenever the valency of iron is +2, that is known as ferrous. So here it's Fe2O3, the valency of iron here is +3. So it's ferric oxide combines with aluminium to form aluminium oxide, it's Al2O3, and iron. This is an example of which type of reaction it's asked. And according to the example, according to the question, this is an example of displacement reaction, because the options that are given are all incorrect. Only option D, that is displacement reaction, is correct. But apart from displacement, we'll talk that which other options could be correct for this type of reaction. So first, balance equation. Here I have two iron atoms. Here just one, so make it two. Here I have two aluminium atoms. Here just one, so make it two. Now oxygen on both the sides is 3. This side also it's 3. So it's already balanced. Now this is an example of displacement reaction, because aluminium is more reactive than iron, and so it is displacing iron from displacing iron from ferric oxide. Apart from displacement reaction, I told you that every displacement reaction is also an example of exothermic reaction, as well as is an example of redox reaction also. Every displacement reaction, single displacement reactions, are all examples of redox reactions also. Okay, so this is an example of displacement reaction, exothermic reaction, and redox reaction. So every displacement reaction is always an example of redox as well as exothermic reaction also. It's very, very important. Just remember that. Now, next one is what happens when dilute hydrochloric acid is added to iron fillings. Okay, so when you are adding dilute hydrochloric acid to iron fillings, iron is more reactive than hydrogen, and so it will displace hydrogen from hydrochloric acid. So the reaction that will be taking place is the third one I'm discussing. Iron is there and we are adding dilute HCl to it. What will be formed will be ferric chloride and hydrogen gas will be formed. This is an example of displacement reaction. Why it's occurring? Because iron is more reactive than chlorine. I hope you remember the reactivity series where we have learned it with the mnemonic, that is करण ने कार मांगी ऑल्टो जेन फरारी पापा बोले हंगामा क्यों होगी आगे और पिटाई. Okay, so just refer to that video if you haven't seen that mnemonic for remembering the reactivity series. that will help you out to remember that. Okay, so based on reactivity series, we can easily work out that iron being more reactive than hydrogen, it will displace hydrogen from hydrochloric acid, and so ferric chloride and hydrogen gas will be formed. Now um, let's see that is it an example of some other type of reaction also. Every displacement reaction is redox as well as exothermic reaction also. Now what is asked in the question is option A is correct, because it says that iron chloride will be produced. Along with that, there will be escape of hydrogen gas. So there is escape of hydrogen gas. Apart from that, ferric chloride will be produced. FeCl3, iron chloride or ferric chloride will be formed. You can call it as iron chloride also and ferric chloride. Okay, so that's option A, that is the correct answer. Okay, now coming to question number 5. Question number 4 we have already discussed in the theory part, you can refer to that. And then question number 5 also, we are not only just going to balance the equation. With every equation we are just going to see which type of reaction is that. Okay, so if you want to take a screenshot, you can take. I'll shift to side. Now we'll work out question number 5, that is balancing the equation. So the first is hydrogen combines with nitrogen to form ammonia. With every reaction, just think about it. Which type of reaction is it? So here I have 2 nitrogen atoms. That side, on right hand side, I just 1. So to make it 2, I'll just multiply with 2. Then here I have 3 times 2, that is 6 hydrogen atoms. Here it's 2, to make it 6, I'll just multiply it with 3. Okay, so nitrogen combines with ammonia to form, nitrogen combines with hydrogen to form ammonia. This is an example of combination reaction. You can see that very easy, no? 2 elements are combining together to form a single product. Now, the second one is hydrogen sulfide, H2S, combines with oxygen, that is O2, to form water, H2O, and sulfur dioxide. Okay, so in this reaction, first let's balance the equation. So this side I have 2 oxygen atoms and this side I have 3 oxygen atoms. Okay, so let's make it at least 2. Try with that, and if it doesn't work out, we'll make 3. Okay, so let's make it 2. Now I have 4 oxygen atoms this side, and this side I have just 3. To make it 4, let me multiply this also with 2. Let's see if it works out. So now I have balanced my oxygen, but what about hydrogen? Hydrogen this side it's 2 times 2, that is 4, and on left hand side is just 2. So to make it balanced, I need to multiply this side also with 2. But what about sulfur then? Now sulfur is unbalanced, so sulfur this side it's 2 and this side it's only 1. So I have to make it 2 as well. But now our oxygen is once again unbalanced. So let's see how many oxygen atoms are there in this side. 2 times 2, it's 4. 4 plus 2, it's 6. So this side also I need to have 6 oxygen atoms, and for having 6 oxygen atoms, I need to take 3 molecules of oxygen. Okay, so now my reaction is balanced. It's always a hit and try method. You can just start with any of the elements and try to balance the equation. Okay, then recheck that everything is balanced or not. This is one of the most important reactions that is asked for balancing. Okay, so it's very important because it's really a good one to balance. Now coming to the type of reaction. So here from hydrogen sulfide, hydrogen is being removed, and removal of hydrogen is known as oxidation. Removal of hydrogen is oxidation. So there is oxidation Sorry, I have given a wrong spelling. So there is oxidation of hydrogen sulfide and oxygen is combining with hydrogen. Adding of hydrogen is reduction. Adding of hydrogen, I told you, it's reduction. So there is reduction of oxygen to form water, and there is oxidation of hydrogen sulfide to form sulfur dioxide. Okay, so this is an example of redox reaction, but no one is going to ask you like which type of reaction is that. Okay, probably they are not going to ask you, but in case they ask you, you are ready for every question. Now the next one, barium chloride reacts with aluminium sulfate. We have already seen this reaction in the previous question also. Barium chloride, again we are doing that, combines with aluminium sulfate. Aluminium sulfate is Al2SO4 whole thrice. Don't just sit and just watch the video, try to work it out by yourself. Forms aluminium chloride AlCl3 and barium sulfate. Now let's start balancing. 3 sulfate ions are there this side, just make it 3. Now barium, this side needs to be 3. Now look at aluminium, it's 2 aluminium atoms here. So let's make 2 aluminium chloride there. And now just look at chlorine, it's getting already balanced. Okay, so this is a reaction. You all know that it is an example of double displacement reaction as well as precipitation reaction, because barium sulfate occurs as white precipitate. Now next one, potassium combines with water to form potassium hydroxide and water. Sorry, potassium hydroxide and hydrogen gas are formed. Okay, so potassium reacts with water to form potassium hydroxide and hydrogen gas escapes out. You can see that is an example of displacement reaction also, as well as that's actually a very exothermic reaction. Sodium or potassium, they combine with water and catches fire. So it's a highly exothermic reaction. Now here let's us balance that. So here I have 2 hydrogen atoms. Here I have 3. So at least we need to just make it 2 this side. So now how many hydrogen atoms are there? 2 plus 2, that is 4. Here just I have 2 hydrogen atoms. To make it 4, I'll multiply it with 2. Now let's see if it's balanced or not. Potassium, I have to make 2 this side. Now let's see about oxygen. 2 oxygen atoms are there in this. 2 oxygen atoms are there in this. Hydrogen, it's 2 plus 2, 4. This side also it's 4. So the reaction is balanced. You can take a screenshot if you want. Now let's consider question number 6. In this, you are asked again to balance the equation, but we'll be balancing and we'll be writing the type of reaction as well. Okay. So question number 6A part. So much to balance, huh? So I hope this will give you a very good practice of balancing the chemical equations as well as finding out the type of reaction. So first one is nitric acid combines with calcium hydroxide. HNO3 is nitric acid, combines with calcium hydroxide to form calcium nitrate and water. Okay, so now this side I have 2 nitrate ions. This side just 1, so make it 2. Now calcium is balanced. Now look at oxygen and nitrate I have taken here, considered here. So it's balanced now. So I am not going to count this oxygen atoms. I'm just going to count the oxygen atoms present here. So here I have 2 oxygen atoms, but in water I have just 1 oxygen atom. So let's make it 2. Now consider hydrogen. 2 plus 2 times 2, it's 4 hydrogen atoms that side. Here I have 2 times 1, that is 2, plus 2, 4. So that is also balanced. Which type of reaction is this? Nitric acid is there. HNO3, with the passing days you will find that this HNO3 is nitric acid. and calcium hydroxide is a base. So acid combines with base to form salt and water. That is an example of neutralization reaction. Apart from that, since exchange of ions is taking place, means calcium is taking nitrate ion from nitric acid. So it's also an example of double displacement reaction. Now C part, sorry, the B part. Sodium hydroxide combines with sulfuric acid, again a neutralization reaction, because sodium hydroxide is a very strong base and sulfuric acid is really a very strong acid. Acid plus base gives salt and water will be formed. So what will be formed is Na2SO4, that is sodium sulfate, and water will be formed. Now let's balance it. Two sodium ions are there, so this side also it should be 2. Sulfate, it's balanced only. Now count the hydrogen atoms. This side it's 2 hydrogen here and 2 here. So it's total of 4. Here it's just 2. So to make it 4, I'll multiply it with 2. 2 times 2 is 4. Now let's count oxygen atoms. So this side it was 2 plus 4, that is 6. This side is 4 plus 2, that is 6. So that is also balanced. Okay. This is also a neutralization reaction, but about neutralization reaction you will read in another chapter, in chapter number 2. Now, C part, silver chloride combines with sodium nitrate. Silver chloride combines with sodium nitrate to form silver nitrate, that is AgNO3 is silver nitrate. You should know the name as well as the formula of each and every compound. Whether it's given in the form of formula in your book, then also they can ask you the same thing in the form of words. Instead of writing AgNO3, they can write silver nitrate in words, and you have to figure out its correct formula. So writing the correct molecular formula is really very important for this chapter. Silver nitrate will be formed and sodium chloride will be formed. Okay, now let's see if it's balanced. It's already a balanced equation only. Okay, so it's already balanced. Now coming to D part of the same question. Barium chloride combines with sulfuric acid. So BaCl2 combines with H2SO4 to form barium sulfate plus hydrochloric acid. Let's first balance it and then figure out the type of reaction. So sulfate is balanced, barium is also balanced, hydrogen it's 2 here, chlorine also it's 2 here. So we have to take 2 HCl molecules that side. Okay, so now it's a balanced chemical equation. Which type of reaction is it? It's a double displacement reaction. Okay, I hope that is fine for everyone. Before we proceed to next question, just take a screenshot. Now let's consider question number 7. Again, we will be doing the same thing in question number 7 as well, practicing a lot of reactions. Calcium hydroxide combines with carbon dioxide to form calcium carbonate and water. So let's balance it. Calcium is already balanced. Count the number of oxygen atoms. It's 2 plus 2, 4 this side. Here it's 3 plus 1, again 4. Hydrogen it's 2. That side also it's 2. So it's already a balanced equation. Now working out the type of reaction, that's not asked in the question. But I'm telling you that this is an example of neutralization reaction. How come it's neutralization reaction? Calcium hydroxide is basic in nature, and in the next chapter, that is acids, bases and salts, you will learn that carbon dioxide is having acidic nature. That is why when it mixes with rainwater, that causes acid rain. Okay, so non-metal oxides like sulfur oxide, nitrogen dioxide, carbon dioxide, these are all acidic in nature. So its base plus acid gives salt and water. So this is also an example of neutralization reaction. But even if you in this question you are not able to figure out the type of reaction, that is completely fine for now. But with the year and when you will revise this chapter once again, that will not be a problem for you, because you will be reading the remaining concepts like carbon dioxide is acidic in nature, and then it will not be a problem for you to figure out the type of reaction. Now, next one, I am hope that I'm not making the things difficult for you. Next is zinc combines with silver nitrate. It's very easy, I hope. That forms zinc nitrate, ZnNO3 whole twice. Why whole twice? Because zinc is +2 and nitrate is -1. Zinc nitrate is formed and silver is formed. Very easily you can find out that this is an example of displacement reaction. Zinc being more reactive than silver, it displaces silver from silver nitrate solution. Apart from that, this is also a redox reaction as well as a exothermic reaction. Silver ko gussa aa gaya. So just balance that. Here we have 2 nitrate atoms, so this side also it needs to be 2, and for that reason silver also needs to be 2. Okay. Now, third one, aluminium reacts with copper chloride to form aluminium chloride AlCl3 plus copper. Again, an example of displacement, redox, and exothermic reaction. Let's find out. It's 2 here, it's 3 here, chlorine atoms. So, to make it balance, I'll multiply this side with 3 and this side with 2. So, it's 6 chlorine atoms on both the sides. Now, look at copper, it's 3 this side, so it needs to be 3 this side also. 2 aluminum atoms are there, so this side also have to multiply it with 2. Very easy one, now. Now, next one is barium chloride combines with potassium sulfate. Barium chloride is reacting with everyone. Barium chloride combines with potassium sulfate to form. What is form? That you should be able to work out by yourself by now. Okay, barium sulfate will be formed. Barium sulfate will be formed plus potassium chloride will be formed. KCl. KCl, NaCl, they have a very strong bond. Okay, so this is an example of double displacement reaction as well as it's a precipitation reaction because of formation of barium sulfate. Barium sulfate is solid, white precipitate. Now balance the equation. Here I have 2 chlorine atoms. So this side also I need to have 2 chlorine atoms. Potassium is balanced. Barium and sulfate are already balanced. Okay, so we have balanced the equation. Next question number 8 we'll be discussing, but before that you can take a screenshot. Now considering question number 8. First part, potassium bromide combines with barium iodide. Potassium bromide, it's aqueous and it combines with barium iodide, that is also aqueous, to form potassium iodide and barium bromide. Barium bromide occurs at precipitate, so it will be solid. Potassium iodide will be aqueous. Okay, this is an example. Now let's balance that. So here I have 2 iodine atoms. This side also I need to have 2. Potassium is 2 this side. Now I need to be having 2 potassium atoms this side also. Barium is 2 this side and that side also it's 2. So it's balanced. Bromine it's 2 this side and that side also, right hand side also it's 2 bromine atoms. Barium, it's 1 here as well as here. So it's a balanced chemical equation. It's an example of double displacement reaction as well as a precipitation reaction. Barium bromide occurs at precipitate. It's solid. It's a precipitate. Now, B part of the same question. Zinc carbonate, that is solid. When it's heated, it forms zinc oxide, that is again solid, and carbon dioxide gas escapes out. This is an example of which type of reaction. So it occurs when it's heated up and one reactant is going to form two products. So whenever a single reactant decomposes to form two products, that is an example of decomposition reaction. Okay, this is a thermal decomposition reaction because that occurs when you are heating it. This triangle shows that it's heated. Now the third one, hydrogen combines with chlorine to form hydrochloric acid. We already did that. Hydrogen is gas, combines with chlorine gas to form hydrochloric acid. That will also be formed in the gaseous state. Since two hydrogen and two chlorine are there, so I need to have two molecules of hydrochloric acid. This is an example of combination reaction because two reactants combining together to form a single product. Very easy to work out. Next is magnesium combines with hydrochloric acid. Magnesium combines with hydrochloric acid. Now you know that magnesium is more reactive than hydrogen. And what will be formed is magnesium chloride plus hydrogen gas will escape out. Okay. To balance it, I need to have two here. Rest everything is already balanced. This is an example of which type of reaction? That is a displacement reaction. So this is displacement reaction. This was an example of combination reaction. This was decomposition. And that is double displacement. Okay. So in this question only in the book it was asked to figure out a type of reaction, but we have done it for every reaction that we have seen. So you can just take a screenshot. Okay. I hope you have taken a screenshot. Now question number 9 is differentiate, like we have to explain exothermic and endothermic reaction. We have already discussed a lot about that. We have seen the activity also to see endothermic and exothermic reactions. For examples, you can say that for endothermic reaction when energy is required, that is photosynthesis. For exothermic reaction, the example is respiration. Apart from that also, all the decomposition reactions are endothermic in nature and all the displacement reactions are exothermic in nature. So you can write any of the examples. Next question is, why is respiration called exothermic reaction? Question number 10. So you know that ATP is formed, energy is produced, so respiration is known as exothermic reaction. Question 11, why decomposition reaction is said to be opposite to that of combination reaction? So in combination reaction, two reactants are combining together to form a single product. But in decomposition reaction, a single reactant breaks down to form two products. So they are known as opposite to each other. 14th question is coming directly to 14th question. 12 and 13 we are not discussing. We have already discussed in the theory part. 14th is a good one. In refining of silver, the recovery of silver from silver nitrate solution involves displacement of copper metal. Write down the reaction involved. So that we'll be writing that. Question number 14. We have silver nitrate and now we take copper. So what will be formed is copper nitrate will be formed. Apart from that, silver will be formed. Okay. So that will be the reaction that will be occurring during the refining of silver. And this is an example of displacement reaction that will be occurring. Now question number 15. You have to explain precipitation reaction with example. We have already done 2 experiments for precipitation reaction. You can refer to the video if you haven't already seen that. Question number 17 also we have worked out. Shiny brown element X on heating in air becomes black in color. Name the element X and the black color compound formed. So the X is copper. When it was heated, it combines with oxygen present in the atmosphere and forms copper oxide, that is black in color. Question number 18 states that why do we paint iron articles? So we paint iron articles to prevent them from rusting. Rusting is a form of corrosion, and in case of iron articles they get corroded in the presence of oxygen and water. If any one of the two are absent, then rusting could be prevented. And we paint the iron articles so that they don't come in contact with moisture and air in the atmosphere, and so that rusting could be prevented. It is a method of preventing rusting of iron. Now let's see to some extra questions that are not there in your NCERT book, but these are the questions that have came in the previous years. So let's discuss some of the questions from the beginning itself. If we are preparing the previous year's papers, previous year's questions, the one that is not already covered in the theory portion that we have seen, that will be really helpful for you at the last. Okay. So I'll just erase the board and we'll see the questions that are not there in your NCERT book, but still they were asked in the previous year. So the first question is, what would a student report after nearly 30 minutes of placing strips of aluminium, copper, iron and zinc in freshly prepared iron sulfate solution taken in 4 beakers? So a student takes 4 test tubes or 4 beakers, and in each of the beaker the student has taken ferrous sulfate solution. Ferrous sulfate is FeSO4. Why ferrous? Because here the valency of iron is 2. So it's called ferrous. I told you that whenever the valency of iron is 3, it's known as ferric, and whenever it is 2, it's known as ferrous. So in first test tube, he is putting aluminium strip. Second one, copper. Third one, iron only. And the fourth one, it's zinc. Now remember, the color of ferrous sulfate solution is green. The color of ferrous sulfate solution is green. So now when we are adding aluminium to it, if you remember the reactivity series, it's Karan, Ne, Car, Mangi, Alto, Zen, Ferrari, Papa Bole, Hangama, Q, Hogi, Aage or Pitai. So according to the reactivity series, you can say that aluminium is more reactive than iron. So here displacement reaction will occur and aluminium sulfate will be formed. Ferrous sulfate, remember that ferrous sulfate is green in color, copper sulfate is blue in color, and aluminium sulfate and zinc sulfate, they are colorless. Remember this thing. Okay, aluminium sulfate as well as zinc sulfate, they are colorless. So this solution will become colorless because of formation of aluminium sulfate. Aluminium being more reactive than iron, it will displace iron, and so aluminium sulfate will be formed. If we add copper, copper is less reactive than iron, you can see. So no reaction will be taking place, copper sulfate will not be formed. No blue color solution will be formed because copper is less reactive than iron, so no reaction will be there. Here we are adding iron only, so no change will be there. The color will remain the same. Here we have added zinc. Now you can see zinc is more reactive than iron. So reaction will be there, displacement reaction will be there, and since displacement reaction will be taking place, so what will be formed is ZnSO4, and ZnSO4 is colorless. It's colorless. It's colorless, and so the solution will turn colorless. Okay, it's a good one, no? It's all based on the knowledge that you've gained in the chapter, but just you need to apply that knowledge. Not difficult one for you. Next question is, aqueous solution of which of these is colorless? So it's again based on the same only. So the question is, ferrous sulfate? No, it's green in color. Zinc sulfate? Yes, it's colorless. Aluminium sulfate? Yes, it's again colorless. And the fourth option is both B and C, that is both zinc sulfate and aluminium sulfate. So yes, zinc sulfate and aluminium sulfate both are colorless. So the answer is both B and C. Now, next is, when hydrogen sulfide gas is passed through a blue solution of copper sulfate. Now let's work out the reaction. So we have copper sulfate solution. We have copper sulfate solution, and now we are passing hydrogen sulfide gas through it. Pass through it, we get a black precipitate of copper sulfide. Copper sulfide is formed, that is in the form of black precipitate is obtained, and sulfuric acid is formed. What else is formed is sulfuric acid. Now the question is, in the solution, this reaction is an example of which type of reaction? Okay, it's very easy. So this is an example of double displacement reaction, because from sulfate, copper is taking the sulfide from here, okay, and sulfate is taken by hydrogen. So hydrogen is taking up the sulfate and copper is taking up the sulfide ions. So it's an example of double displacement reaction. Very easy to work out. Next question is, on heating blue colored powder of copper nitrate. Now it's quite similar to the one that we have done as an experiment, thermal decomposition of lead nitrate. I hope you remember that. We have seen that the brown fumes of nitrogen dioxide are formed. So the next question that we are going to discuss, it's similar to that. But just in the question in the board exam, they have changed the compound. On heating blue colored powder of copper nitrate. Copper nitrate is blue in color. We are heating it. In a boiling tube, black colored copper oxide, oxygen and a brown gas are formed. Identify the type of reaction. So when we are heating it, copper nitrate is a single reactant. Let's write the reaction first. Copper nitrate, this is CuNO3 whole twice. It's copper 2 nitrate given. So the valency of copper here, it's given in the question, it's copper second nitrate is given in the question. So means copper exists in the form of +1 as well as +2. It's given the question that the valency of copper in this is 2. So it should be written like this. We are heating it, means we are getting thermal decomposition reaction. What is formed is copper oxide, oxygen, and a gas is formed, that is X. Okay, X named gas is formed. Identify the type of reaction. So it's a thermal decomposition reaction. You can see that. Write a balanced chemical equation. We have already written that. And the gas formed will be, we know that the brown fumes are formed because of formation of nitrogen dioxide. So the gas X is nitrogen dioxide. We have seen the brown fumes in the experiment as well. Write the balance equation. We have already done that. Okay. One more part of question is there that you will not be able to work out right now, but after completing the syllabus you will be able to work out. So the exams happens at the year end. So in the same question, sometimes they ask the concept based on 2 different chapters. So the third part asks you, write the pH range of the aqueous solution of the gas. So if you pass this gas through water, then what will be the pH of that solution? So nitrogen dioxide, I told you that acid rain, you all remember. Just remember acid rain. So why acid rain occurs? Because of the water getting combined with carbon dioxide, nitrogen dioxide, sulfur oxides present in the atmosphere. So these all non-metal oxides are acidic in nature. And since they are acidic in nature, the pH range will be acidic. You will come to know that the pH of acids is somewhere between 1 to 7. It's less than 7. Okay. So the pH will be less than 7. So the answer for the third part is that the pH will be less than 7, that is acidic in nature. Okay. Now the last question, just which of the following reactions is not possible? That is also based on displacement reaction only. I'll be writing 4 reactions. Tell me which one of them is not possible. Zinc combines with copper sulfate to form zinc sulfate and copper. The solution color will be changing. It will become colorless. This is blue and this is colorless. Okay. Second part is iron reacts with zinc sulfate to form iron sulfate and zinc. Third part is zinc reacts with ferrous sulfate. You know, ferrous sulfate is green in color, to form zinc sulfate, which is colorless, and iron. And D option is aluminium combines with ferrous sulfate to form aluminium sulfate plus iron. Okay, so which of the reactions is not possible? This reaction is not possible because iron is less reactive than zinc, so it cannot displace zinc from zinc sulfate solution. Okay, here 4 is not clearly visible. Okay. So this reaction is not possible. Rest all the reactions are possible because a more reactive element in all the rest of the 3 equations are displacing the less reactive element. That's all for this chapter. We have completed the entire chapter along with discussion of some extra questions as well. I hope you were able to understand the concept. I hope the video is quite lengthy, but still you were able to understand all the concepts from the chapter. Do let me know in the comment section what do you feel about the video. That's all for today. Good day everyone.